In this video, we're going to have a look at using factorials to find numbers of arrangements of different objects. So imagine we have the cards A, B, C and D, and we can arrange them in any order, but only using the cards once. This means that there will be 4 positions that each of the cards could take. So for example, I could have A, B, C, D, I could have A, B, D, C. You can imagine there would be a lot of different arrangements that are possible. So we need a method to be able to calculate how many ways there are of doing this. So let's consider the positions. If I was taking my first card, there would be 4 cards to choose from. Once I've taken my first card, there are now only 3 cards to choose from for the second position. For my second position, there are now only 2 cards left, and for my fourth position, there is only 1 card left. So to calculate the number of arrangements, I can multiply 4 by 3 by 2 by 1, which gives us 24 different arrangements. Now, this could also be written as 4 factorial, because a factorial means if we have n factorial, we do n multiplied by n minus 1, multiplied by n minus 2, and so on all the way down to 1. So 4 times 3 times 2 times 1 can be written as 4 factorial. Now, imagine if we have the same letter repeated. So let's this time consider I have 4 cards, but I've got 2 A's, a B and a C. So I've still got the same situation that I've got 4 cards to choose from. I've got 3 cards for the second position, 2 cards for the third and 1 card for the fourth. That's still saying the same. That's still 4 factorial. However, some of my combinations will look the same. So, for example, if I picked A first and second, well, I could choose the same A but in a different place and it would look the same. So when we have repeated values, we actually need to divide by our repeated value as a factorial. So I've got 2 A's, so I'm going to divide by 2 factorial. This means when I've got 2 values that are repeated, I've actually only got 12 arrangements this time because some of them would have looked the same because the A's have the same value. Now let's consider that in my arrangement, I had to have a certain letter at the beginning. So let's say I have to have an A as my first number. Then I'm only looking at the next 3 digits, which will be our 3 factorial. The A is set in stone, it's only 3 we need.